when we talk about sets, you all do know about sets. Sets aren't anything strange to you. It's just that in mathematics, now you're going to formally learn how to define a set, how to identify the elements of a set, how to enumerate or list the elements of a set, and you'll also learn about proper set notation. Okay, so for starters, when we talk about a set, obviously a few things will come to mind. A set is a collection, and when we talk about sets in mathematics, we're talking about a collection of elements, all right? A collection of objects. And these objects could be anything. It could be people, it could be names, it could be um, shapes, it could be numbers. But the key idea is to remember that a set is simply a collection. So before you formally met the topic of sets, you all were dealing with sets. You all were dealing with sets of numbers. You all recall the sets of numbers that you all have interacted with at Form 1 level, right? Directed numbers. Yeah. So set of directed numbers is one. So generally, the sets that you all would have met in Form 1 in terms of numbers would have been natural numbers, whole numbers, integers, which is the set of directed numbers. You have rational numbers, where we talk about those fractions. You have irrational numbers. You have real numbers. So outside of mathematics, you all would have interacted with sets. And the first set that you all would have met would have been things like gender, all right? Boys versus girls. You all would have met those types of sets, all right? Families, you all would have met, brothers versus sisters, boys versus girls. Also, I don't know if you all can recall from primary school where you all would have met the set of living things and non-living things. I don't know if you'll remember those things. Oh yes, at least. Good. So ideally, sets is around us in the world, and we do interact with them, but today you're going to learn to formally identify a set and the elements which belong to a set. Let's get started with defining a set. All right. So like I was saying, a set is a collection of objects, and they can be grouped together, some based on characteristics that they have in common, but sometimes you have sets that don't have really any kind of common characters. All right, like I was saying, a set is a collection of objects. All right, so a collection of objects could be about absolutely anything. It could be, like I was saying, a group of numbers. It could be letters. It could be shapes. It could be people, places. You name it. You name it, you could definitely create a set out of something. All right. So, animals, for instance, we have sets. All right. So, general idea that you need to get is that sets is basically a collection of objects. All right. Now, there are different types of sets. We will get into them in a little bit. But the main set that you are going to learn about is the universal set. And that universal set is the one that contains everything. And within the universal set, there are little other sets which contain, a different collection of objects. Okay. So, first and foremost, what is the set? The set is a collection of elements, all right, or objects. Right. So I'm not going to get into union and intersection just yet. I just want to get the general idea of sets down. All right. So we'll come back to all the details here in a little bit. All right. So yeah, here we go. So first things first, when we talk about set notation, we need to know that we can denote a set by a capital letter. So any general set, we can label it A, B, C, D. We just need to make sure that we define the set properly. So in this example, all right, let's talk about the symbols and everything that we see in here. All right. So given that U, use our universal set, has the numbers from 1 to 20, and A is the prime numbers between 1 and 20, and B is the odd numbers between 1 and 20. We'll talk about all these things after, but here's what I want you all to do for me first. First of all, I want you to list all the elements in the set U. I want you to list all the elements in the set A, and I want you to list all the elements in set. One person will tell me what are the elements in U. One person is going to tell me the elements in A. Next person is going to tell me the elements in B. All right, so anybody ready to share? Anybody ready to share, or when listing the prime numbers between 1 to 20, do we add 20 at the end or no? Okay, so here's what you need to remember. First of all, what is a prime number? All right. Then when you can recall the definition of a prime number, you'll be able to identify the numbers that you think should be in that set. From there, you need to know that sometimes the values that they tell you to list between or whatever, those values don't necessarily have to be members of the set. Okay, so my first question would be, is 20 a prime number? All right, and if your answer to that is yes, then 20 should be in that set. But if the answer to that is no, 20 should not belong to that set. Okay, so the set of prime numbers, I really don't want to explain it until we started to go through it, but the set of prime numbers would only contain prime numbers, meaning numbers that are divisible by 1 and itself. And since you're asking if 20 belongs to the set, remember 20 is not a prime number, but aside from that, general thing to note, sometimes when they ask you to list out the elements of a set, the numbers that they say to go between don't necessarily have to belong to the set. Okay, so did you include 1 in the set of prime numbers? No, exactly. So you understand what I'm trying to say? 1 and 20 don't necessarily need to belong to your set. Okay, the set 1 and 20 will belong to will be the universal set, because the universal set contains all the members from 1 to 20. All right, so something very specific as well that we need to know about, with sets is the language. When they say numbers from 1 to 20, this means 1 and 20 included. But if they said numbers between 1 and 20, 1 and 20 won't be included. Okay, so from 1 to 20, these would include 1 and 20. Between 1 and 20 will not include 1 and 20. All right, another way they also say it, from 1 to 20 inclusive, that means you are to include the numbers 1 and 20. I saw a message pop up in chat. Right, so yes, English is very, very specific in, you're welcome, yeah. So English is something, as much as most math people might say, well, they're not good at English. To be pretty honest, the logic in mathematics requires an understanding of English to an extent. So when you have a very fair understanding of English and the constructs, you will be able to translate English to math with no problem at all. Let's see. Okay, so the elements in the set U, the elements in the set A, the elements in the set B. So somebody tell me, Kayla, what do you have in your universal set?
1 to 20.
1 to 20. All right, so we start at 1 and we end at 20.
Yeah.
Yeah, all right. All right, let me just scroll up a little bit, pinch. Right, so there we go. At the bottom here, we have U is the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, going all the way up to 20. All right, so remember that the English here was very specific. It said numbers from 1 to 20. Now, my prime number set. So, Laria, you tell me what is in the set of prime numbers.
2, 4, 6, 8, 10, 12, 14, 16, 18.
Primes?
Yes.
You sure that's primes?
Primes. Oh, shucks. Wait, no.
Primes even. That's the one that you did for me. Instead of prime numbers, you did even numbers. So take a look back again. Aha. Let's see who's popping in the chat. I realized, lol. Yeah, it happens. So this is why I mentioned, nah, don't beat up yourself. All right. This is why I was saying we need to know those definitions of those sets from Form 1, because when we deal with sets in mathematics, you will notice they might bring a lot of numerical problems. All right, they'll bring ones testing your knowledge of the number sets. So that's why you need to know the difference between a prime, a composite, an even, an odd, a real, an integer, all these things. All right. So when you check over and you get your prime numbers, tell me, and we'll check it out and see how right you are this time. Okay, so let's just begin with this. All right. So I have 6 minutes again remaining. First of all, composite numbers refer to all those numbers that have multiple factors. Okay, so for example, 2 is an example of a prime number, but 6 is an example of a composite number, because 6 is not just divisible by 1 and 6, it is also divisible by 2 and 3. So a composite number is any number that comprises of multiple factors. All right, whereas the prime number only has 2, one on itself. Okay, Larry. No. 4, 6, 8, 9, 10, 12, 14, 15, 16, 18. I think you list out the composites, Diana. Yeah, those looking more like the composites. All right. One more try. All right. In the meantime, Krisha, set B's a little easier. Tell me, what do you have for odd numbers? 1, 3, 5, 7, 9, 11, 16, 15, 17, 19. Very good. No, Ilaria. No, you're not. You're mixing up yourself a little bit, so that's why I need to go back through definitions of these sets from Form 1. Try to establish an understanding of the definitions. So I think prime numbers can only go into themselves. No, not just themselves. They are divisible by 1 and itself. Remember, prime numbers have 2 factors, 1 and itself. So an example, like I said, is 2. All right, and there are several other numbers that are divisible by 1 and themselves.
So 3
Yeah.
would be a prime number as well.
Yes, 3 would also be a prime number.
Oh, okay. So it's like I forget things and then like yeah.
Yeah, it's happened to all of us. Beautiful.
Yeah.
There we go, Ilaria. 2, 3, 5, 7, 11, 13, 17. Just one more. One more, Miss Ilaria. Just to recap where we're at, the last thing we touched on was listing out the elements of a set. All right. So we listed out the elements of U, the elements of A, and the elements of B. All right. So seeing as U is a set of numbers from 1 to 20, we established that 1 to 20, from 1 to 20 means that we are going to include the numbers 1 and 20. So when we look at the list of elements in the set U, we notice that we start at 1, we count every single number from there all the way up to 20. When we discussed prime numbers, we said that since the set A is the prime numbers between 1 and 20, the prime numbers, which we know are numbers that only have 2 factors, those prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. And because prime numbers were between 1 and 20, that's the reason why we only considered the numbers which fall in that range between 1 and 20. The next set that we had to look at would have been the set B, which is the set of odd numbers between 1 and 20. So again, because the list is asking us for numbers between 1 and 20, we list out the odd numbers that fall in that category. All right. I'm supposed to take out 1. It's a good thing I have the other documents open. Yes, I'm going to take out 1 from that. All right. But the correct, so the correct thing would be from 3, go all the way up to 19 odd steps. All right. Okay, so we're going to look at doing a couple of things in a little bit with those sets, but the next thing that we're going to look at is part B to this question, where we list out the elements of particular sets. All right, so you'll do union and intersection already, or you'll just look at union. So let's get started. The first thing is, when we deal with sets, all right, I'm going to stop looking at your chat. If you could even call that expedite. Oh, Lord. Okay, I'm going to stop looking at your chat. All right, back to what I was saying. So the reason for being able to identify the elements of a set is not just to list out sets, because there are many things that we can do with sets. Sets are actually quite useful for solving problems, and we also apply probabilities when we look at sets. Okay, so before we even get to all those wonderful things, we need to understand all there is to sets. All right, so let's just think about a couple of things, for instance. All right, so in real life, like I was saying, there are many sets that we encounter. All right, so we will encounter sets among human beings, among animals, among living things, non-living things, plant life, etc. All right, and basically when we have a collection that brings together 2 sets, this is what we call the union. Okay, so for instance, you can say that in primary school, for some of us who went to mixed schools where you had boys and girls, your classroom would represent a universal set, which could be broken up into 2 sets, the set of boys and the set of girls. Another way that we can also, oh, they are serious. I'm just gonna mute this chat just now. I'll be about yourself. Hey, I'm serious. Every time I see that orange,
Sorry, miss.
every time I see that orange, is like, ugh, it just in my eye. Anyway. All right, back to what I was saying. So, aside from the universal set, we also have what we call the union and the intersection. All right, the union of sets really and truly brings together 2 sets which were not necessarily together. When we talk about the union, we talk about the elements which belong to, let's say I wanted the union of the sets A and B, as we have here with this part 1. Let me just get back the Krisha, like your waterfall.
Thank you.
I know I've seen it. All right, let me just get this back. All right. So yeah, like I was saying, A union B. This U here is not universal set. This U here means union. So when I'm talking about the union of 2 sets, I'm talking about bringing together the sets A and B. All right. So the sets A and B, when we want to bring them together in a union, they're both bringing the elements they each carry. So A has its own elements and B has its own elements. So when we bring A union B together, we are compiling the elements of both sets into one. All right. Okay, so for instance, right, let's just take a simple look at something in everyday life. When you all come together to study, right, Carisha might know something, Kayla might know something, Ilara might know something, all right? So 3 of you would have some little bit of knowledge of your own. When you come together as one study group, you're uniting all your bits and pieces of information together. And together now you all will have much more information together than separately. Okay? Another way to look at it is like pooling together resources, pooling together things that you all have. If for some reason we manage to not be in COVID again, and we decided to get together at lunchtime to have a snack party, and Kayla brings some kind of snack, Trisha brings something different, Larry brings something different, you bring all three together. Together now you have not just the snack that you had by yourself, but you also have the others' snacks as well. If I want to look at the union of the sets A and B, I am going to look at the elements in A and the elements in B, and I'm going to put it all together in one. All right. So the set A union B is the set which brings together the elements of A, which are 2, 3, 5, 7, 11, 13, and 17, and 19, as well as the elements of B, which would just be 3, 5, 7, 9, 11, 13, 15, 17, 19. Okay, and I'm going to put all those people together in one. I forget to take out this one again. Oh my goodness. Anyway, so y'all just ignore this one. I will delete it out of the PDF later. But your union will have 2, 3, 5, 7, 9, 11, 13, 15, 17, and 19. All those elements will belong to A union B. All right. So what I want to point out, let's just think about it like this. If two people are getting married, they're bringing together their separate families into one big family. All right. So who was in family A and who was in family B? When A and B get married, they bring everybody together. So it's one big family in the union. All right. Simple as that. There we go. Ilaria looking all studious. Barely seen Ilaria. Like, I don't know why. I just like hearing the music with the lull. Dead. Alright. So, like I was saying, common members of the two sets don't need to be rewritten a second time. And once you are able to identify the elements of sets and you want to find a union, you just put them all together. All right. The next thing that you will need to know about is the intersection. So the intersection means what is in common in both sets. Okay. So we're looking at the sets A and B, and we want to figure out what both sets have in common with each other. Okay. So when we talk about intersection, we are looking at the numbers in A that also belong to B. All right. So when I'm looking at the prime numbers between 1 and 20, I see that I have numbers like 3, 5, 7, 11, 13, 17, and 19, which are also elements of B. All right. So when I'm asked to list out the elements in the intersection, I'm just looking for what is in common, what both sets have in common. All right. So union brings together two sets. Intersection finds what is in common. All right. Make sense so far? Yeah? All right. Now, I'm not going to jump into complements, but I want to mention now the English when it comes to the union and the intersection. So the word that is associated with union is or. All right? Or as in O-R. Or. So whenever you see the word or, we're talking about union. All right? So if I were to phrase the question instead of telling you to list out the elements of A union B, if I said list the elements of A or B, you are to list out the union. All right. So when you see the word or is asking you for the elements which belong to the union of two sets. When it comes to intersection on the other hand is associated with the word and. So whenever you see and means intersection. So if I ask you, what are the elements of A and B? This is the intersection of the sets A and B, and the elements which belong to both sets, what is in common to both sets, those are the elements that will be in your intersection. All right. So if I ask you all for union, remember, bring together all the elements of the respective sets. And if I ask you for intersection, I'm asking you for the elements that belong to both sets. All right. So I want you all to try one now. So I'm gonna just scroll in a bit. All right. You'll do Venn diagram as well, by the way. Anybody?
No.
No. Okay, so we're not gonna jump into all that detail. All right. For a while, this is what I want you all to do. So all right. So I want you all to write down this one here. This one. All right. Let A be the set of prime numbers between 3 and 10. Let B be the numbers from 1 to 10. Okay. What you're going to do is this. You're going to list the elements of A, list the elements of B. All right, so I'm marking it up. Ready? Let A equal prime numbers between 3 and 10. The amount of things I've seen on how to edit it. Anyway, let A equal prime numbers between 3 and 10. I believe.
Can you repeat what you said? My internet.
Okay, just now. So I believe you'll understand that whenever you're talking about sets, you have to use curly brackets. You'll understand that much, right? Yeah? I think I see Laria nod. You all know that whenever you have to write the set, whether you write it like this or you write the elements of the set, you have to put curly brackets, right? Kayla?
Yeah.
Right. I'm just making sure you're right. Okay. So I'm gonna say a question, but just give me a minute.
Comma, 5, comma, 7, comma, 3, 7, 2, bracket.
What are we writing?
No. Wait.
All right, let's go. So let's begin. The one that I want you all to do for me is as follows. Ready? You're writing. Let A be the set of prime numbers between 3 and 10. So the notation you're using is A equal, open curly bracket, prime numbers between 3 and 10, and then close your curly brackets. So the only word that I'm missing here is numbers, all right? So just remember what I just said. Let A be the set of prime numbers between 3 and 10. And let B be the set of numbers from 1 to 10. All right, y'all, one thing at a time, please. The first thing, the common end that I use, because I can't get mathematical symbols, I use the common end for intersection, all right? The second thing is this. There is a symbol N. There's a symbol N in sets that you usually use to indicate number of elements in a set, all right? So when you all have set notation things, the symbols you all need to remember. Okay, so remember, I just used the lowercase n here because I don't have the math symbol for intersection, but only in this particular situation I use that for intersection. All right, in the document you will see the symbol for intersection, which is the upside down looking U. The next thing is n in sets. If you see n open bracket a close bracket, that means number of elements in a set. Okay, all right, so I'm gonna email you all the document that I'm sharing with you all right now. That's this document. I will send you all this email. All right, like I was saying, I have another version that I was working on. I'll send you all that when we reach there. All right, so what you all haven't done as yet, don't stress too much on it. We could always touch on that another time. But for the while, I want you all to make sure and internalize how you represent sets. All right, first of all, how do you define a set? What are the elements or members of a set? The notation that you will be using to represent a set. So always remember, you are going to be using a capital letter to denote a set. When you want to list out the elements of a set, you will use curly brackets. And even when we are stating, just like how I have it here, U is equal to the numbers from 1 to 20, we use the curly brackets as well. So anytime you are, whether you are listing the elements in a set or you are naming a set, you must remember to use curly brackets. Okay? So what are the important things that you need to take away from today? Tell me one thing that you recall that we talk about before we wrap up. Anybody?
A set is simply a collection.
Okay, so it's just a collection. Collection
A
of.
union brings two sets that not necessarily together.
Yeah, that's right. Anybody else has anything they want to share? Anything else that they learned? All right, so my question, how do you denote sets? What do you use to denote a set?
Capital letters.
Very good, capital letters. What is an element of a set? Anybody? All right, so if that one went over the heads of my students, I want you all to remember, whenever we're referring to an element of a set or a member of a set, just remember that an element or a member of a set is simply an object that belongs to a set. All right, something as simple as that. So, for instance, when we were talking about the numbers from 1 to 20, any number from 1 to 20 will belong to a set as defined, and that is an example of where you can get the members of the set. So if I said, is 3 a member of the set U, you would say yes, 3 is a member of the set U. All right? Okay. So we mentioned union. Anybody remembers intersection?
Yeah.
Yeah, what is the intersection of the sets?
The numbers that both in common in the two sets.
That's it. All right, so the intersection is what is in common in both sets. All right. And once you know, like I said, once you know how to denote sets properly, once you know what is the union, once you know what is the intersection, you have a basic idea of starting to work with sets. All right, so union and intersection, as well as the number of elements in a set, is going to play a very important role later on when you start to do the algebra related things with sets. All right, because sets aren't just used to list out elements, as I was saying. Sets can be used to solve problems, and those problems can involve things like figuring out how many people have something in common, how many people like a particular sport, how many people participate in sports. You'll realize that there are many, many problems in real life that you can use. Yes, Ilaria. Okay, Kayla, an element or a member of a set is simply an object that belongs to a set. All right. So just remember, like I said, it's simple. What you need to remember is that an element is an object that belongs to a set. Yes, Ilaria, like I was saying, algebra in sets. Because you're going to be solving problems in maths which have unknowns. Unknowns mean variables. Variables mean algebraic terms. Algebraic terms mean X and Y's. So yeah, that's where you're going to start seeing algebra again. Make sure you don't forget or unlearn everything in algebra, because you're going to realize algebra is something that you can't escape. Once you're doing mathematics, algebra is going to be somebody that you need to make your best friend, because algebra comes to haunt you in every single thing if you don't make algebra your best friend. You'll need to, let me tell you all something, right? This is life lesson number 1. Regardless of what you're doing in life, just remember that things will always pose a challenge to you in the initial stages. All right? So don't ever let first impressions get you feeling like you're never going to get something. You just need to be patient with yourself, all right? Yes, practice. One of the things that will help you with mathematics is practicing, making sure that you get sufficient practice. Just take it one step at a time. All right, be patient with yourself. You're not, as I always tell my students, you're not expected to be the best student immediately. Everybody has to have some sort of challenge if they're learning anything at all. All right, and I'm not saying that you're going to struggle through everything, but some point in time, you'll meet a topic that will give you a challenge. And if you are really a lifelong learner, if you are really a good student, you're going to embrace the challenge and you're going to figure out a way to overcome it. All right? So, yes, has ended up preaching too much. But anyway.
What is the session without you preaching, honestly?
I know, right? Are we good students? Yes, you're good students because you're actually following up on the things that you don't know. All right? So, all I want you all to make sure and do from every session, take away important things. That's the reason why I will ask you at the end of every session, what did you learn from today? All right? Because the important thing is that you figure out what the way it benefits you. I feel like I'm the most miserable. Yes, the most miserable one. I'm joking. All right? So, always remember, patient with yourself. All I want for you all to do, practice, revise, make some time to rest in between, because that is important as well. All right? And
too, just saying.
What?
Yes, you need to rest.
You need to rest, yeah.
One sleep.
Yeah, you need to rest too.
You need it more though.
Yep.
Yeah, I know.
I'm exhausted.
This week was just a little extra exhausting. I don't know why. I think I just tired with life. But anyway, this is life. This is how it goes. Some days good, some days not. All right. So yes, you'll enjoy the rest of your evening. I'm going to send you the email with this document attached to it. So look out for it in a little bit. Bye bye, people.